June 1932, Royal Small Arms Factory, Enfield. British ordnance officials introduced the service's intended replacement for the heavy 4.55 Webley revolver. The response from many officers was immediate and blunt: embarrassment. The new Enfield No. 2 fired a noticeably smaller cartridge, felt lighter in the hand, and beside the bulk of the Webley looked almost toy-like. One senior officer is said to have quipped that it was a sidearm fit for clerks and typists. Meanwhile, the German Luger had earned near-mythical status after 1918, the prized war trophy of the Western Front, coveted for its perceived Teutonic precision and polished finish. The initial impression was that Britain had answered German engineering excellence by stepping backwards. That surface judgment, however, missed the point. In harsh, dirty, and neglected combat environments, the Enfield No. 2's unadorned robustness would outlast the Luger's delicate precision. The Great War had exposed a problem. The 4.55 Webley, though powerful, was difficult for rapidly trained conscripts to use effectively. Its heavy recoil made accurate shooting hard for minimally trained troops, and wartime training time and ammunition were scarce. Post-war assessments concluded that a simpler, more controllable pistol that a soldier could learn to operate quickly and hit with at short ranges was more valuable than an elegant but demanding high-powered handgun. German thinking followed a different line. Georg Luger's P08, designed at the turn of the century and adopted by the Navy in 1904, fired the 9x19 Parabellum at around 1,150 to 1,180 feet per second, energies in the mid-300 foot-pound range, roughly double the energy the British adopted for their replacement revolver. The Luger's toggle lock action was a mechanical marvel, a jointed knee-like arm that flexed to cycle the action, producing a clean trigger break and a naturally pointing grip angle that suited instinctive shooting. On a clean firing line, with good ammunition and regular maintenance, it was superb, accurate, rewarding to shoot, and much admired by Allied troops who risked punishment to keep captured examples. But in the field, the Luger demanded more than most ordinary soldiers could supply. It was sensitive to ammunition quality. Underpowered or variably loaded rounds could cause short cycling. The toggle linkage and precisely machined mating surfaces accumulated fouling and required frequent cleaning and correct lubrication to function reliably. Springs lost tension, and fine tolerances rapidly degraded with grit and neglect. A Luger that performed perfectly one day could be temperamental the next under battlefield dirt, mud, or carbon fouling. At Enfield, Captain H.C. Boys, later known for the Boys anti-tank rifle, led efforts to develop a more forgiving service arm from about 1926. Webley and Scott had offered a .38 design in 1923. The Enfield No. 2 was adapted and refined, improving lockwork, the trigger mechanism, and adding a removable side plate to allow easier maintenance by soldiers in the field. By the early 1930s, the Enfield No. 2 was formally adopted, around 1932, as the standard service revolver. Its specifications reflected conscious trade-offs. The service pattern used a 5-inch barrel and fired the .38 200 cartridge, a 200-grain bullet at modest velocity, around 620 to 650 feet per second, producing roughly 176 foot-pounds of energy. The revolver had a 6-shot cylinder and a top break action with an automatic extractor that simultaneously ejected all spent cases when opened. At about 27 ounces unloaded, it was lighter than a Luger and much simpler to operate under stress. The top break and automatic extractor offered a major practical advantage over magazine-fed pistols and swing-out cylinder designs. Reloading under fire was quicker and mechanically simpler. The Luger required removing a magazine, inserting a fresh one, and racking the toggle to chamber a round, steps that could be fouled by grit or a damaged magazine. The Enfield's double-action trigger rotated the cylinder and cocked the hammer in a single pull. Single action remained available when a deliberate, lighter trigger press was desired. The whole lockwork could be removed through a side plate for field maintenance much more easily than the Luger's interlocking precision parts. The choice of the heavy 200-grain lead bullet reflected a period theory about terminal effect. The understabilized, heavy projectile tended to yaw and tumble on impact, producing larger wound channels in testing on cadavers and animals during the 1920s and 30s. British authorities argued it matched the .455 Webley's stopping effect, even if it did so with far less overall energy. That claim has always been optimistic. The .455 remained physically more powerful, but the smaller revolver's advantage lay in handling and the likelihood of hitting the target in the first place. Legal concerns then interceded. The original Mark I's soft lead projectile raised questions over international law, the 1899 Hague Declaration concerning expanding bullets, and by 1937 Britain adopted the .38 Mark II-Z, a 178-grain gilding metal jacketed bullet at slightly reduced velocity to remove any appearance of contravening the Hague rules. That alteration also required sight changes to compensate for the modified ballistics. Functionally, the Luger's exposed toggle was a practical vulnerability. Unlike slide systems that enclose and protect the action, the toggle linkage protruded and readily collected dirt, grit, and carbon. The finely machined mating surfaces and tight tolerances that made the Luger so accurate also made it unforgiving in the dirty realities of combat. A revolver, by contrast, has no feeding mechanism to jam. Pull the trigger, and the cylinder indexes mechanically. There are fewer springs and sliding parts to foul or lose tension. The U.S. Army's early 20th century trials illustrated this point. After testing 1,000 Lugers in tropical and expeditionary conditions in the Philippines and Cuba between 1901 and 1907, the U.S. report concluded the Luger was not recommended for service because its certainty of action, even with Luger ammunition, wasn't satisfactory. The Americans chose the Colt 1911 instead. Germany itself recognized the Luger's limitations and began work on a replacement well before WWII, eventually adopting the Walther P08 in 1938.
Production efficiency also favored simpler designs. Sources note the Luger required around 14 man-hours to produce, compared with roughly 8.5 man-hours for the later Walther P38. Yet wartime needs and retooling constraints kept the Luger in production into the early 1940s. One consequential change at Enfield produced the Mark I Star variant in June 1938. The hammer spur was removed, and the action converted to double action only, producing a heavier trigger pull, around 10 pounds. A widely repeated explanation, that tank crews wanted the spur removed because it snagged on hatch edges, is likely apocryphal. Research and original change notices indicate the real drivers were production economy, the spur was time-consuming and costly to manufacture, and a desire to standardize training on one mode of operation. The issued tanker holster also covered the hammer, making the spur practically redundant. How did these design philosophies play out in combat? In North Africa, the Enfield No. 2 served with the 8th Army from 1940 to 1943. Desert operations tested small arms mercilessly. Fine abrasive sand, extreme temperature swings, and limited maintenance opportunity punished tightly toleranced automatics. The Lugers carried by some Commonwealth allies and by German forces were frequently compromised by grit in the toggle, while the simpler Enfield revolver continued to function with only minimal attention. During much of the Desert Campaign, the Enfield and older Webleys remained the principal personal sidearms until higher quantities of the Browning high power reached the theater. Cold climates told a similar story. In the Winter War and the Continuation War, Finland used large numbers of Lugers, notably the M23 variant, and combat experience there highlighted the problems of automatics in extreme cold. Wrong lubricants thickened into glop, springs lost tension, and exposed mechanisms jammed. The forgiving revolver became an attractive option where reliable function rather than peak ballistic performance mattered. At Arnhem in September 1944, paratroopers of 1st Airborne carried both Enfields and Webleys. Photographs from the Oosterbeek fighting show Enfields in the hands of airborne troops amid shattered houses. The revolver remained standard issue for officers, vehicle crews, specialists, and many who needed a dependable, easy-maintain sidearm. In jungle warfare, the British supplemented domestic production with large numbers, about 900,000, of Smith & Wesson Victory revolvers in .38-200 built in the United States, reflecting a conservative preference for revolvers in humid, maintenance-challenging climates. Personal testimony reflects the practical truth. Veterans often remarked that the tiny .38 Enfield was unglamorous but reliable. Many soldiers preferred single-action-capable Smith & Wesson or Webley alternatives when they could obtain them, complaining that the Mark I Star's long double-action trigger degraded accuracy beyond short ranges. Nevertheless, the core praise from modern reviewers is blunt. The Enfield No. 2 just worked without requiring obsessive care.
Production totals underline the scale of use. RSAF Enfield produced roughly 300,000 to 380,000 Enfield No. 2 revolvers between 1930 and 1957. Around 55,000 were original Mark I with spur examples, many later converted to Mark I Star configuration. Additional wartime manufacture came from contractors like Albion Motors Ltd., Glasgow, Coventry Gauge and Tool, and the Singer Sewing Machine Company. Distribution prioritized vehicle crews, officers, RAF aircrew with RAF-marked frames and thigh holsters for tankers and armored corps, Royal Navy officers, SOE personnel, and airborne formations. The Enfield No. 2 remained in British service through Korea and was not formally displaced until April 1969 when the Browning High Power completed transition to the standard-issue pistol. Colonial police forces used Enfields in Hong Kong, Singapore, and Malaya into the 1970s, and Israel produced unlicensed copies from 1951 through 1974. By contrast, the Luger's production ran to roughly 4 million examples across many manufacturers, and it remained popular worldwide for decades. Swiss and Norwegian arsenals retained Lugers well into the 1980s. Its enduring appeal as a target pistol and collector's item testified to its qualities, yet Germany's own replacement decision in 1938 reflected the fact that its performance came at the expense of a demanding maintenance burden unsuited to many frontline conditions. Put simply, the two weapons embody different design philosophies. The Luger prioritized theoretical performance, high velocity, a naturally pointing grip, a fixed barrel, and brilliant machining for accuracy. The Enfield prioritized practical reliability, simpler mechanism, looser tolerances, easy maintenance, and a design soldiers could keep running with little support. In a prolonged total war, those practical advantages mattered. Manufacturing time, maintenance needs, and training costs multiply across hundreds of thousands of weapons and thousands of frontline users. The enduring irony was that when Enfield production alone could not meet demand, the War Office bought Webley Mark IV revolvers, the very type previously rejected as wartime stopgaps. Webley later sued for development costs. The courts denied the principal claim, but the Royal Commission on Awards to Inventors granted them a modest award, £1,250, in partial recognition. Finally, the long-running man-stopper myth that the .38-200 equaled the .455 Webley in sheer stopping power deserves sober scrutiny. Physics and ballistic testing do not support equivalence. The .455 had greater energy and larger diameter. The .38's advantage was that it made it more likely the shooter would actually hit the target under stress. Troop preferences often leaned away from the double-action-only Mark I Star model. Soldiers swapped for single-action revolvers where available.
But modern evaluations from seasoned firearms historians and collectors are clear. The Enfield No. 2 just worked, a decisive virtue when automatics jammed, ammunition varied, conditions dirtied mechanisms, and training time was limited. War is not a target range. Maintenance schedules fail, lubricants thicken, ammunition varies, and soldiers are exhausted. A pistol that functions reliably when everything else degrades is worth more in combat than a pistol that excels only in ideal conditions. British Ordnance recognized that forgiveness could be more valuable than elegance. They designed a service revolver to match the grim realities of war, not the pristine scores of bench tests. The Enfield No. 2 never won beauty contests. It lacked the Luger's cachet, and many troops grumbled. But it fired when needed, remained robust in deserts, jungles, and cold, and it multiplied across theaters for decades. Adequacy, in this case, beat excellence, because adequate still functions when excellent is jammed.